FastMCP 2 implements dependency injection through a declarative parameter resolution system, where runtime values are automatically provided to tool functions based on type annotations or explicit dependency declarations. This mechanism decouples component configuration from execution logic, enabling clean separation between client-facing parameters and internal service dependencies. We'll examine how custom dependencies are defined using the depends wrapper and injected into tool functions, with the framework handling resolution order and caching automatically. The upcoming code demonstrates synchronous and asynchronous dependency providers working together within a single tool implementation. From FastMCP, import FastMCP. From FastMCP dependencies, import depends. MCP equals FastMCP, custom deps demo. Def get config dict. Return API URL. https://API example com, timeout, 30. Async def get userid int. Hash could fetch from database, external service, etc. Return 42. At MCP, tool. Async def fetch data. Query, SDR. Config, dict equals depends get config. Userid, int equals depends get user ID. SDR. Return F userid fetching. Query from config API URL. This code demonstrates FastMCP's dependency injection system for creating custom dependencies, a core pattern that separates configuration and runtime values from business logic. The example shows two dependency providers: getConfig, which returns a configuration dictionary, and getUserid, which simulates fetching a user identifier. These are injected into the fetchData tool using depends, allowing the tool to focus solely on its core functionality, while FastMCP handles the dependency resolution. The pattern follows FastMCP's convention, where dependencies are declared as parameter defaults using depends, making them invisible to MCP clients while remaining available to the function implementation. This approach enables clean separation of concerns, as the tool signature only exposes the query parameter to clients, while internally having access to both configuration and user context. The dependency system automatically handles caching and resolution order, ensuring efficient execution even when dependencies are shared across multiple parameters. This technique is particularly valuable in production systems where configuration, authentication, and other cross-cutting concerns need to be consistently available without polluting function signatures or requiring manual propagation through call stacks. By using depends, developers can create modular, testable components while FastMCP manages the dependency graph and lifecycle automatically. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which provides the core functionality for implementing Model Context Protocol MCP servers. This class serves as the foundation for creating MCP-compliant server instances that can register and expose tools for remote procedure calls. From FastMCP dependencies, import depends. Imports the depends class from the FastMCP dependencies module, which is used for declaring dependencies in FastMCP applications. MCP equals FastMCP, custom deps demo. Creates an instance of FastMCP with the identifier custom deps demo that will be used as a server label in MCP protocol handshakes. The string parameter serves solely as a human-readable identifier for client recognition during protocol initialization. Def get config dict defines a function named getConfig that returns a dictionary. The function signature indicates it takes no parameters and is expected to return a dictionary object containing configuration data.
Return API URL. https://API example.com. Timeout 30.
Returns a dictionary with two key value pairs. API URL mapped to the string https://API example com and timeout mapped to the integer 30. This provides configuration values that would typically be used for API requests, specifying both the endpoint URL and a 30-second timeout duration.
Async def get userid int.
Defines an asynchronous function named getUserid that returns an integer value. The function signature indicates it will retrieve some user identifier, but doesn't show implementation details in this segment.
Return 42.
Returns the integer value 42 from the current function.
@MCP tool.
Decorates the following function as a FastMCP tool, enabling automatic registration with the Model Context Protocol framework. The decorator signals that this function should be exposed as a callable tool in the MCP interface, with its name, description, and parameter schema derived from the function's signature and docstring.
Async def fetch data.
Defines an asynchronous function named fetchData that takes no parameters. The async keyword indicates this function will perform non-blocking operations, allowing other code to run while waiting for its completion. The function signature suggests it's designed for I/O-bound operations like network requests or database queries, though the specific implementation isn't visible in this segment.
Config. Dict equals depends.get config.
Declares a function parameter named config with type annotation dict that will be dependency injected by calling getConfig when the function is invoked. The depends marker indicates this is a FastAPI style dependency that will be automatically resolved by the framework.
Userid. Int equals depends.get user ID.
Declares a function parameter, userid, with type annotation int, that will be automatically resolved by calling the getUserid dependency function. The depends marker indicates this parameter's value comes from FastAPI's dependency injection system rather than being passed directly by the caller.
Return f userid fetching query from config API URL.
Returns a formatted string containing the user ID, the query being fetched, and the API URL from the configuration dictionary. The string follows the pattern userid fetching query from API URL, where the values are interpolated from the variables and config dictionary. FastMCP2's dependency injection system cleanly separates configuration and runtime values from business logic through declarative parameter resolution. The depends wrapper enables automatic injection of both synchronous and asynchronous dependencies, as demonstrated by getConfig and getUserid. These dependencies are resolved automatically by the framework, with FastMCP handling resolution order and caching behind the scenes. The key insight is how this pattern maintains clean function signatures. The fetchData tool only exposes the query parameter to clients while internally receiving both configuration and user context through dependency injection. This approach enables modular, testable components where cross-cutting concerns like configuration and authentication remain invisible to the client interface while being consistently available to the implementation. The framework's automatic management of the dependency graph ensures efficient execution without manual propagation through call stacks.
The function grabs its depends like a magician, pulling rabbits from an empty hat.